Hey guys, Mr. Yisley here. So we're on to lesson number 22 in chapter 4, all about writing linear functions. And in lesson number 22, we're going to start talking about how to graph these arithmetic sequences. So in the last lesson, we talked about how to extend them out, how to figure out more numbers within them. But what we're going to talk about here is how to graph them. So within this, there's kind of 4 things that we need to do. All right. First is that we have to use the sequence. So I'm just going to kind of give you an example sequence, and we're just going to say, hey, we've got this number of 5, 10, 15, 20. So we had a 4-term sequence that they gave us. All right. The first thing we need to do is we need to let the term's position in the sequence be the x-coordinate, because in order to graph a sequence, we have to have ordered pairs. All right, got to have ordered pairs. Now, ordered pairs, typically, we use these x and y coordinates, right? But in these ordered pairs, we're going to, instead of using x, we're going to call that n, right? And instead of using y, we're going to call that a of n, or n of a, however you want to say it. So here we go. These are what we're creating. So again, back to step 1, let's let the term's position in the sequence be the x-coordinate, or the n. So when we're talking about its position in the sequence, kind of like I talked about in the last lesson, 5 would be the first term. So its position in the sequence would be 1. So we would have an ordered pair of 1, and then that would be the x-coordinate. All right. Then we let the term itself, so whatever its number is, be the y-coordinate. So for example, this one right here of 5, it would have an ordered pair, or be an ordered pair of 1, 5. Because the x-coordinate, or also known as the n, all right, that's 1, that's the position in the sequence. The term itself is 5, so that would be the y-coordinate, or the a of n. So that's how we determine the ordered pairs. Well, once we've created the ordered pairs like we did right there, then we're going to graph those ordered pairs. So again, first thing you got to do, let the term's position in the sequence, so is it the first term, second term, third term, be the x-coordinate, or also known as n. Then let the term itself be the y-coordinate, all right? So that's how we create those things. All right, once we've figured out the x and the y-coordinate, or the n, a of n, as we talked about, we create the ordered pairs, and then last thing, we go in and graph those. So when we do this, always pay attention to what kind of graph you're going to need. Do you need a 4-quadrant graph? Can you use a quadrant 1 graph? What makes sense? So we've got specifically 2 examples that we're going to go through on this. And so in example A, it tells us to graph the arithmetic sequence of 4, 8, 12, 16, and then tell us what you notice about it. All right, so I'm going to move this up a little bit so we can get it all on the paper. All right, and so first thing I want to do again, step 1, let the term's position in the sequence be the x-coordinate. All right, so where it is in the sequence. So like 4 is the first term, 8 is the second term, 12 is the third term, 16 is the fourth term. Then let the term itself be the y-coordinate, and then we create the ordered pairs off of that. So again, this was the first term, second term, third term, fourth term. So when I go to create those ordered pairs, I should have ordered pairs of, and again, remember, this is the n, a of n. I should have an ordered pair of 1, 4. That would be my first ordered pair. My second ordered pair would be 2, 8. My third ordered pair, 3, 12. And my fourth ordered pair, 4, 16. Because remember, this is the first term, so that's its n coordinate, all right, or x, whatever you want to call it. This is this, and then the y coordinate, or the a of n, right, is the fourth, or is 4. So we let the term itself be there. So we've created our 4 ordered pairs of the 4 terms they gave us in the arithmetic sequence. So now what we need to do is we need to go in and graph those. Well, first thing I notice is that all these numbers are positive. So I know I can work with a quadrant 1 graph. So I'm going to go ahead and do that. I also notice that if I label by 1s on the n-axis, which is like the x-axis, right? I'm going to be fine. I can fit it all on there. If I label by 2s or even 4s on the y coordinate or the a of n, I'm going to be fine. I can fit it all on there. So I don't need one of those little crazy marks to show that I'm skipping. All right, so just a normal quadrant 1 graph. Now again, I want to label it. My x-axis is known as n. We call it n in an arithmetic sequence. And then the y-axis is known as a of n. Right? That's what we call it in arithmetic sequences. And we'll learn more about that here in a later lesson. So then I want to go in and I want to label my axes. So for the n's, they're counting by 1s because they're positions in a sequence. So 0's right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now n's, they're counting by 4s, so I could count by 4s, but I know that I can still fit it on if I count by 2s. I'll have a little better spacing, so I'm going to count by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Now, it would not be wrong if you counted by 4s. It just has to be consistent all the way across. So I've labeled my 2 axes. I've got them shown what they're counting by, so now I need to go in and graph my ordered pairs. So 1, 4, that tells me to move right 1 and up to 4. So there's my first point on this arithmetic sequence. Second point, 2, 8, so right 2 and up to 8. Third point, 3, 12, so right 3 and up to 12. Fourth point, 4, 16, so right 4 and up to 16. And there I have graphed my points. All right. Now the last thing they've asked us to see is, what do you notice about these points? Well, you probably noticed that they were adding 4 every time in the arithmetic sequence. Probably noticed that right away. I also know that these points are going in a very straight line. And as we talked about back in chapter 3, that is known as linear. So we're not going to draw a line through it, but we might say that we noticed that the points are linear, increasing by 4. Are linear, increasing by 4. And that's what I would say I noticed. All right, well, I'd encourage you to try example B, so flip your paper over. There's one more example there at the top. I'd encourage you to try that on your own, then check your answer with mine. So example B says graph the arithmetic sequence of 3, 6, 9, 12, and then tell what do you notice. All right, well, when I look at this, again, I need to determine position in the sequence to get my x-coordinate, or also known as the n-coordinate. I need to determine the number it is itself to figure out my y-coordinate, or the a of n. So again, when I'm just going to label these, and I'm going to say, hey, this is my first term, second term, third term, fourth term. And then I'm going to create those order pairs of n, a of n, which is the same as x and y. All right. So first order pair, 1, 3. Its position in the sequence is 1. The number itself is 3. Second order pair, 2, 6. Its position in the sequence was second, and the number was 6. Third one, 3, 9. And fourth one, 4, 12. So hopefully you're getting a hang on how that works. Now I've got to go in and I've got to graph these order pairs now that I figured them out. So when I go to graph them, I notice that they're all positive numbers. So again, working in a quadrant 1 graph. I also noticed that they're all kind of increasing by 3 in the y part, or the a of n. They're only increasing by 1s in the n's, or the x. So I can fit it all on the graph easily. Don't need to do anything crazy here. So again, the y-axis is also known as the a of n when it comes to arithmetic sequence, and the x-axis is known as n in arithmetic sequences. N's are increasing by 1, so I'm just going to label by 1s. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, these are increasing by 3. I just like to count by 2s. It gives me some nice, easy numbers to work with. You could count by 3s. You could even fit counting by 1s on here. And actually, let's do that. Let's count by 1s on here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I can fit all my numbers on there. So you could really count by anything as long as you can get the numbers that you have to work with on there and it's consistent. So last point, now we need to graph the order pairs. So 1, 3 is my first order pair, so move right 1 and up to 3. Second point, 2, 6, right 2 and up to 6. Third point, 3, 9, right 3 and up to 9. And last point, 4, 12, right 4 and up to 12. All right, so what do we notice about this one? Well, it's kind of similar to example A in terms of those points are kind of going in a line, right? Well, arithmetic sequences are pretty much going to follow that. They're pretty much always going to be linear, right? So what do I notice? I noticed, right, the points are linear and increasing by 3. Pretty simple, right? So for every time I move 1 on the end, the A of n is increasing by 3. All right, well, that's how we graph arithmetic sequences, right? If you have any additional questions on this, please let me know. But otherwise, you should have what you need to continue on in the chapter.